And so we will have our last speaker for this segment, who will be Anais, about moving beyond APIs, the advantage of ArrowFlight SQL for efficient data retrieval. Hi, Anais.
Hi, thank you so much.
Let's go in again. Let's keep your original time for people who wants to hear the full story of InfluxData, right?
Sure thing. Thank you.
Nice.
Give me 1 second here to get set up. Yeah, I really appreciated Mary's talk. That was very interesting. So today I want to talk about moving beyond traditional APIs like ODBC and JDBC and really get into the advantages of using ArrowFlight SQL for efficient data retrieval, especially from databases. Just to introduce myself briefly, my name is Anais Dotis-Georgiou, and I'm a developer advocate at InfluxData. For those of you who aren't familiar with developer advocacy, what it is someone who represents the community to the company and vice versa. And so I try to create example repos of how to use our technology with other technology to help get you started, create blog tutorials, give talks like these, and also bring user feedback back to product so we can make sure that we're in alignment with what our customers and users need. And I encourage you to come and connect with me on LinkedIn. So today we're going to be talking about provide some background and give some background around the history of APIs like JDBC and ODBC. Talk about why they were created and what they do well as what they don't do well. And then I'll introduce Apache Arrow, because we can't really talk about Apache Aeroflight SQL without talking about Apache Arrow and understanding how they symbiotically benefit each other. And last but not least, I will finish off by talking about the advantages of Apache Aeroflight SQL and also share some learning resources so that if you have any more questions around anything regarding this talk or InfluxDB or time series, you have some direction and some places to go to. So before we talk about Apache Arrow and Apache Aeroflight SQL and the advantages that it provides for transferring and transporting data between databases or services, I wanted to take a look at the existing APIs to provide some kind of historical context for why ArrowFlight SQL and Arrow were even kind of created to begin with. So ODBC. So ODBC is a standard application programming interface. It's an API for accessing database management systems. It was developed, I think, in the early 1990s, largely by Microsoft, but by a bunch of different companies. And the goal was to create a DBMS agnostic API for accessing data in a uniform way. It uses SQL as its database access language, and it provides a set functions for function calls, error codes, and data types. And then we saw the emergence of JDBC. So JDBC, Java Development Kit, was introduced in the Java Development Kit in I think the 90s too, quickly after ODBC. And it was largely influenced by ODBC in many ways and can pretty much be viewed as a Javaized version of ODBC. Like ODBC, it allows a developer to write an application that can access a variety of DBMS, but it's specifically designed for Java and is more in line with Java's object-oriented principles. And it was really created to address the need for the standard way that Java interacts with databases. So a little bit more on why JDBC was actually created. The main reasons why it was developed, despite the existence of ODBC, is that it provides a language-specific API. So ODBC is more C-based, which makes it, less than ideal for using with Java, since it's object-oriented. And another reason is that it provides platform independence. So this was a key feature of it. Kind of extending this principle of write once and run anywhere. By contrast, ODBC drivers are platform dependent, and this goes against the Java philosophy. Then it also ensures type safety. So it provides compile time type checking, which helps to prevent any errors and enhance code reliability. Another feature is integration with Java features. So it's better at handling exceptions for Java, multi-threading, garbage collection, etc. And then it also has some advanced features like including blobs and different data types, and just has more support. So hopefully we have some understanding now of like ODBC and JDBC and why they were developed, and some of the differences between them. And it's important to note too that while I'll be talking about the advantages of ArrowFlight SQL, they still play a really important role in many ecosystems and are, still very popular and used in many applications. So now I want to introduce Apache Arrow so that we have a foundation for really understanding Apache Aeroflight SQL. And in order to understand why Apache Arrow was even created, let's kind of dive into, what the world is kind of looking like and the push towards it. So, over the past few decades, leveraging big data sets has been an integral part of a lot of businesses' needs because they need to perform a lot of increasingly complex analysis. And so we've seen a lot of advancements in things like query performance, analytics, and data storage. And a lot of these advancements are largely a result of greater access to memory. This greater access to memory is largely in part to things like demand, manufacturing process improvements, and technological advancements. But these lower memory costs have spurred the creation of technologies that support in-memory query processing for OLAP and data warehousing systems, or online analytical processing. And so Apache Arrow, what is it? Well, it's a framework for defining an in-memory columnar data that every processing engine can use. And it aims to be the language agnostic standard for columnar memory representation to facilitate interoperability. And there's a bunch of different tools and companies that leverage Apache Arrow. But I think one important note here is that one of the co-creators of Apache Arrow is Wes McKinney, who's also the creator of Pandas. And he was inspired to, create Apache Arrow because he wanted to make Pandas interoperable with all data processing systems. And this is one of the problems that Arrow solves. And so how does Apache Arrow solve some of these problems? Well, it's gained a lot of widespread adoption because it provides really efficient columnar memory exchange. It provides zero copy reads, meaning that the CPU does not copy data from one memory area to a second. And this reduces the requirements for for memory requirements and CPU cycles. Additionally, Arrow has a columnar-based format, and processing and manipulating data is much faster as a result. And I'll talk about this in a little bit specifically within the context of InfluxDB because it's especially applicable to time series data. And what else can it do? Parallel and take advantage of things like single instruction multiple data, or SIMD, vector processing, and vector querying. And it also has advantages in that it is a standardization in storage. So like I said, it aims to be the standard data format for databases and languages, and standardizing the data costly serialization and deserialization between systems. So any system that supports Arrow can transfer data between them with little overhead. And this is especially important too when we think about using ArrowFlight SQL to transfer that data. We can leverage Arrow with ArrowFlight SQL, then we reap the benefits of not having to handle the burden of serialization and deserialization. Additionally, Arrow offers multi-language support. It contains libraries that allow you to work with the Arrow columnar format in many languages, including Rust, C++, Sharp, C Sharp, Go, Julia, Python, R, etc. So, all these libraries enable developers to work with Arrow. and work with the Arrow format without having to implement the Arrow columnar format themselves. So now let's look at some of the companies and libraries and tools that are using Arrow. So it's really become a building block for a wide range of use cases. Several are in the high performance analytics space, and I just wanted to talk about some of the maybe more famous ones. So first is Apache Spark, and that's a fast general engine for large scale data processing. And Spark uses Apache Arrow to improve performance and conversion between Spark data frames and Panda data frames. We have ClickHouse. ClickHouse is an open source analytical database management system. It uses Arrow for import and export of data, and also for direct querying against external data sets in ArrowStream, Parquet, and ORC formats. Dask is a Python library for parallel distributed execution of dynamic task graphs, and Dask supports using Pyro for accessing Parquet files. Parquet, also for those of you who don't know, is also an Apache project, and it's a durable disk format that's also columnar as well, and it has extremely high compression and is like 17 times more efficient than like CSV, for example. I believe that's the right figure. MATLAB uses Apache Arrow, again, to support reading and writing Parquet files. Pandas, I talked about that a little bit already, so we kind of don't need to go to that anymore. But for those of you who aren't familiar, it's also a data analysis toolkit for Python, where you can manipulate two-dimensional data structures very easily. It's great, I love it. And then we have Dremio as well. And Dremio is a self-service data platform. It makes it easier for users to share data from any source, and it includes a distributed SQL execution engine, and that engine is based on Apache Arrow as well. Yeah, lots of cool projects that are leveraging Arrow. Another cool project that is leveraging Arrow is InfluxDB. So I work for InfluxData, and InfluxData is the creator of InfluxDB. And InfluxDB is a open source time series database, and a lot more. We also have methods for collecting data and visualizing and analyzing data, but we recently rewrote the entire storage engine in 3.0 to be built entirely upon the Apache ecosystem, and that includes Apache Parquet, Data Fusion, and Arrow and ArrowFlight SQL. And the reason why we chose to write on top of these tools is to achieve certain goals. One was to have no limits on cardinality in our data, and this is because in time series use cases, it's very common that, especially like if we think of an IoT use case, where as our project grows and we continuously add maybe more sensors, then our cardinality will grow. And we were finding that there were several users who maybe have, a sort of very high volume throughput, because time series data is generally very high volume of maybe like 800,000 points per second, and they needed their cardinality or the dimensionality of their data to be 50,000 or 100,000. So we're able to address that problem in part by Apache Arrow, because of how efficient the columnar storage is. We also want to provide best-in-class performance on analytics. This is largely due through Data Fusion, which is a query execution engine, but that leverages Arrow, and largely all of the benefits associated with the performance benefits from the columnar database, from the columnar format, are leveraged by Data Fusion, which in turn allows us to have best-in-class analytics. Like, you can't have great analytics if you can't efficiently store your data, right? We wanted also to enable separate compute from storage and tiered data storage, and we achieved this by using Parquet as the columnar disk format and Arrow as the in-memory columnar format. We also wanted to provide operator control over memory usage. you should be able to define things like how you want memory to be used for buffering, caching, and query processing. This is largely achieved through the fact that it's also written on top of Rust, but Arrow contributes to this as well. And then we wanted to also enable bulk data export and import. This will be available through being able to export and import Parquet files directly, but also being able to transfer and transport the Arrow format as well. And last but not least, we wanted to provide really broad ecosystem compatibility, and that's directly associated with the support of Arrow and ArrowFlight SQL. Because yeah, like we said, any system, it aims to be that standard. So any system that is leveraging it means that we can directly transfer ArrowFlight Arrow format through ArrowFlight from one system to another. And so this has already provided interoperability with BI tools like Tableau and Power BI and Grafana and Superset, etc. Yeah, so now that I've talked a little bit about ArrowFlight SQL or Arrow, Apache Arrow, excuse me, and how companies are using it, why it was created, and also how InfluxDB uses it, I want to take some time to introduce Apache Aeroflight SQL. So Apache Aeroflight SQL is essentially, sorry, one second. I lost my slides here for a second. Where did they go? Oh, okay. They're there. Sorry. Okay, so ArrowFlight SQL is a client-server protocol that's developed by the Apache Arrow community, and it's used for interacting with SQL databases, and it leverages the Arrow in-memory columnar format, and it uses the Flight RPC framework, which is built on top of the gRPC framework. So what are some of its goals? Its goals are to provide similar functionality to existing APIs like JDBC and ODBC. It does things like execute queries, creates prepared statements, fetches metadata, etc. And it enables clients to communicate with Arrow native databases without any data conversion. So it saves you all of that process of deserialization and serialization, and also having to transpose row data into columnar and stuff like that. So yeah, some of the main components of Apache Aeroflight SQL is that it is basically two things. It's built on Apache Arrow's columnar format, and Flight RPC, which is built on gRPC. So we're already familiar with Apache Arrow's columnar format. I also want to take a moment here to kind of like emphasize why the columnar format is so performant. And the reason why is because if we think of a traditional table in SQL, where we have a bunch of different columns and rows, if we think about JDBC or ODBC, which converts and stores the rows, works with the data in a row-based format, if you were looking at something like temperature, but then you had a column for location and then a column for pressure, your value types, your types might be like integer, string, float, and they're all different types. Whereas if you represent things in a columnar format, then you are having all of your integer values together. And especially in the case of time series, let's say we're monitoring a room, the temperature of that room likely is not going to change. So we're going to have several data points in a row for that temperature column that are the same. And so when we store those in a columnar format, not only are we not skipping between types, but we also have the opportunity to enable really cheap compression. And by counting, for example, the number of same values and storing that in metadata. So that's just another reason, kind of briefly, of why the columnar format is so much more efficient and makes so much more sense. And then, yeah, Apache Flight Arrow is ArrowFlight SQL is also built on FlightRPC, and FlightRPC is essentially built on gRPC. gRPC is Google's remote procedure call, and it's a high-performance open source framework that is language agnostic, and it is used for defining service contracts and creates really strongly typed client and server stubs. Some of the features that gRPC provides that traditional APIs do not provide, like JDBC or ODBC, is language interoperability. So gRPC supports a wide variety of languages. You can create services in one language and consume them in the other. In contrast, for example, JDBC is only specific to Java. Network communication. gRPC is designed for low latency, high throughput communication between services over a network. This is not the case for JDBC. JDBC is designed for interacting with the database, not for service-to-service communication. So that's another advantage that you get with ArrowFlight SQL. Protocol buffers or protobufs. gRPC uses protobufs, so does FlightRPC, for defining service contracts and message formats. And that leads to way more efficient serialization compared to typical like JSON or XML. Also, it supports streaming in HTTP2, specifically bidirectional streaming, which allows for more efficient communication. And it really supports real-time data because of this bidirectional streaming. So in other words, like if you need to transfer data in real time or near real time from a database to a client application, the server could keep a stream open and push changes to the client as they occur in the database. And this is especially important for things like time series databases, where having things in real time is critical. Yes. Do I want to say anything else about this? I guess one other thing that's important too about FlightRPC is that it does enable data transport in parallel. It provides parallel transfers, which means basically that you allow data to be streamed from one cluster server simultaneously. And so that just makes it more scalable as well. So now I want to talk about some of the advantages of ArrowFlight SQL. So some of the advantages, high level, is that it's more performant and efficient and language agnostic. We've already talked about some of the performance and benefits and how Arrow in general is more efficient, and also all the languages that are supported. It also eliminates the need to design and implement a new wire protocol. So or wire format. So JDBC and ODBC do not define the wire format themselves. Rather, instead, the specific database driver does. And this is because they are more like specifications or interfaces. They define a standard way to interact with the database, but the actual implementation is up to the database vendor. But Flight already provides a wire protocol out of the box, and so this relieves that burden from the database engineers. It also already provides features like encryption and authentication, and this is largely due to the fact that it's built on top of gRPC, and so that also reduces development effort. And so while standards like JDBC and ODBC have served users really well for decades, they fall short for databases and clients which want to use Apache Arrow or columnar data in general and reap those benefits of columnar data, because row-based APIs like JDBC require transposing the data in that case. And for a database which is in its nature columnar, this means that data has to be transposed twice, once to represent it in rows for the API and once to get it back into columns for the consumer. And so, yeah, you don't have to worry if you are using Arrow and ArrowFlight SQL, then you don't have to worry about any of that. So Flight SQL aims to get rid of a lot of these intermediate steps, essentially. So last but not least, I wanted to talk about some of the resources that you can use to learn more about InfluxDB, time series, Arrow, ArrowFlight SQL, etc. So I encourage you to go to our forums, community.influxdata.com. If you have any questions, I'm usually on there and happy to answer. We also have a Slack page where you can also reach out to developers directly, or I can try and put you in contact with them. The developer advocacy team is myself and 2 other people, and we have Influx community on GitHub, where we contain a wide variety of repos that demonstrate how to use InfluxDB with other projects. There are some really cool demos on there. Most recently, we leverage InfluxDB 3.0 in an example repo highlighting the symbiotic nature between using InfluxDB with OpenTelemetry. So basically, we run this sample application that generates traces, and we use Jaeger and Grafana to visualize them, and also store all of the logs, metrics, and traces within InfluxDB, which is very exciting because InfluxDB historically hasn't handled logs and traces that well, but now it does, thanks in part to Arrow and ArrowFlight SQL. And there's a bunch of other really cool demos and examples on there, so I recommend giving a look. We also have our docs. Our docs are fantastic. I love our docs team. We also have blogs where you can find all sorts of tutorials on how to use InfluxDB, or even more information on Arrow and ArrowFlight SQL. And then we have InfluxDB University, which is a learning management system that we've created where, we leverage one, I should say, rather, where you can go and take classes on all things InfluxDB and earn badges and display them on your LinkedIn, and it's all free. So if that's the style that you like to learn in, then I recommend that you check that out as well. And last but not least, if you want to get started, I think the easiest way to get started with InfluxDB, especially 3.0, is to take advantage of our free cloud offering before you even install anything, just to play around with it, get a feel for it. And if you have more interest in it, then you can look at our other offerings. And so, yeah, that pretty much wraps up everything I wanted to talk about today. Thank you so much.
Thank you very much, Anais. So we reached our 25 minutes, but thank you, it was really insightful and a lot of details, a lot of things, a lot of links. It seems a vibrant, tech community, so it's really great. Thank you very much, Anais, and yeah, looking forward to having you as a speaker in another event.
Likewise, thank you so much.
Thank you. Have a good one.
Bye.